We're given a cumulative frequency graph and asked to estimate the median annual salary. Well, let's just remember what cumulative frequency is. It's like a running total, so it tells us the number of people with a salary less than or equal to that given. So, for example, there are 50 people with a salary less than or equal to £50,000. So, if I want to work out the median salary, I want to work out halfway through the data. And I've got 60 people, so I want to look at the 30th person. And I can read off the graph. It's best to draw a line to just demonstrate that you're reading off the graph carefully. And I can see it's going to be £24,000. So half the people will earn under this and half the people will earn above it. Now I've just noticed it does actually have thousands in the answer, so I should just write 24 here. The cumulative frequency problem is then turned on its head because it asks me to get back to the table. Often we do questions where we're given a table and we draw the cumulative frequency graph, but I'm doing the opposite here. So I'm going to need to read off some data points. P less than or equal to 10. Okay, I'm not going to draw lines for all of these, but I am going to put dots down. That's going to be 14. Yeah, 14 people. Less than or equal to 20 is going to be 26. 30 is going to be 36. 50 is going to be 50. And less than or equal to 80 is going to be my 60. I'm then asked to use the information to calculate an estimate of the mean annual salary. We need to think back here. When have we calculated means from sort of continuous data? The only time GCSE is, well, it might be from a histogram actually, but when you do that, you try and go back to a grouped frequency table. So that's what we're going to do here. We're going to kind of take this, and I think I'm going to write the data out in full again. So I've got between 0 and 10. For a grouped frequency table, you don't include the value here. You tend to make it less than, but that's okay. It's okay that we've got less than or equal to 10 here. This is only an estimate, and then I've got a frequency of 14, and then I've got 10 to 20. Okay, and this is where I need to do the opposite of what I'd normally do. Normally we add them up to get the cumulative frequency. I'm going to need to do some subtractions now. So this is going to be 12 to get me to 26. So I'm finding the difference between 26 and 14. Then it's going to be 20 to 30. And that frequency is going to be 10 because it's what I need to get to 36. It's the difference between 36 and 26. 30 to 50. That's going to be 14. And 50 to 80 is going to be another 10. So you can see it's still going to add to 60. Okay, what do we then do? We then find the midpoint, because the midpoint represents the interval essentially. I've got values between 0 and 10. I assume they're evenly distributed, and so some are going to be less than the midpoint, some are going to be more. The midpoint's the one that I'm going to use to represent the whole group there and be able to do a calculation. So I'm just going to write it to the left. No, I won't. I'll write it to the right. So the midpoint is going to be 5, 15, 25, 40, and 65. I've done that just by looking at them, but you can add the two values together. 30 plus 50 is 80 and divided by 2, and that will tell you the value in between. It should be the same distance either side. So 65, 15 less than that is 50, and 15 more than that is 80. So it's okay. And then I need to multiply them together because I'm basically saying I've got 14 values that are 5. I've got 12 values that are 15. So I figure all these out. Use a calculator for this. That one's going to be 70. I think I can. Okay, I know. Let's not rush it because it's very easy to make a mistake. 12 times 15. 180. 250. 560. 650. Add these up. That will tell me the total amount of salary for the 60 people. And finally, to estimate the mean, it's going to be that total amount divided by the number of people, which was 60. And I'm expecting to get a value, you know, around about 30, maybe a bit more. Okay, maybe a bit less, 28.5. So 28.5 thousand. That looks about right. It's in that middle interval. I'm happy with that. Explain why your estimate of the median is more reliable than your estimate of the mean. Okay, I'm going to show you the mark scheme for this. There's lots of accepted answers for this 1 mark. So the median is only affected by mistakes in measuring. You know, when I drew the graph, and then, you know, I measured it, so it should be quite accurate. Whereas the mean relies on, by the way, any one of these I think has would give you the 1 mark. The mean relies on your assumption that the values lie at the midpoint. The median's accurately read from the graph, whereas the mean's estimated. Not sure about that one, because you still have to do it by eye. I'm just going with what it's saying here. The number of people earning each amount is not evenly spread out. That's a good shout. Although you could say that would affect your graph. You know, we're assuming that the graph goes like this. We don't know that. It could go like that. Like we don't actually know the shape. I'm just kind of I'm not putting some doubt into these answers. The mean has no exact values and the accurate line graph instead of an assumption. So I don't know, if I was answering this question, like forget the mark scheme, I'd say like there is some doubt in making measurements from both. Like we don't have raw data. We draw the cumulative frequency graph from a grouped frequency table, so I think there's issues with both. But I think because you're just looking at the middle value, it's going to be a bit more reliable than using all of these like midpoints throughout.